Hi everyone, this is going to be a short tutorial video on how to use the transform feature on your NanoVNA. As you can see here, I have a calibrated NanoVNA with an open circuit load. So as we can see, the yellow trace is the logarithmic magnitude of my reflection coefficient, which simply shows 0 dB across the entire bandwidth. We also see a Smith chart plot in blue, which is just a cluster of points there at the far right end of the circle. Next, I'm going to attach a small length of cable to my NanoVNA. I don't necessarily know how long this cable is, but I'm going to measure its length using time domain reflectometry. So I plug in this length of cable, and you can see the Smith chart exhibits the familiar spiral pattern. And we also see a slight amount of loss as we go high in frequency, which is what we'd expect from a slightly lossy length of cable. Next, I'm going to activate the transform feature on my NanoVNA. Simply tap the screen to activate the menu and select display. And down here is an option that says transform. Now I'm going to activate the transform by clicking this option here. And you'll notice the trace is suddenly very different. That is because the NanoVNA is essentially calculating the inverse Fourier transform of my frequency domain samples on the reflection coefficient. Thus, you see the white text here now is giving me units of time and distance. In particular, if we take the inverse Fourier transform of my reflection coefficient, I get an impulse response of my circuit. So imagine an impulse being sent down this cable, wobbling around, and then hitting the end before reflecting back to give you a sudden spike here after some time delay, which, if we move the cursors here, seems to correspond to about 15-ish nanoseconds, or roughly 1.6 meters. Next, we're going to play with some of the fancy features on the Fourier transform. For example, we can select low-pass impulse, which is essentially an impulse response, but with some different filtering applied to the signal. And again, you see a nice sharp peak right here at about 1.6 meters, or roughly 15-ish nanoseconds. I can also select the option low pass step, which will tell me the step response of my circuit here, which you can see is basically 0 here for a matched load or a matched cable of 50 ohms, which suddenly shoots up to this value here, indicating an open circuit at the end of this load here. Now let's talk about the velocity of propagation. For this particular measurement, the NanoVNA is assuming a velocity of propagation of about 2/3 the speed of light. But hypothetically, it may not be that actual value in this cable. So what you can do is select this option here that says velocity factor, and it's going to ask for a percentage of the speed of light. So for example, if I say 100, this will imply 100% of the speed of light going down this cable. So you notice my time delay is still about 15 nanoseconds, but that will now correspond to a different length of cable. Hypothetically, the velocity of propagation could be, say, half the speed of light, in which case I would just tap the menu, select velocity factor here, and I would put in 50 for 50% of the speed of light. And again, you notice my distance has now changed to represent that slower propagation velocity through my cable. And that's basically it. That is how you use the transform feature on your NanoVNA.